Welcome to Intuition, and in this video we will look at how to create three of your basic solids or primitive solids using CadQuery, namely a sphere, a cylinder, and a box, or let's say a rectangular prism. And I will be modeling the Lego toe ball plate element because we can roughly model this part as a kind of sphere for the toe ball, a cylinder for the bar or neck, and a box for the plate or the body. For the purpose of this video, I will assume that you have CadQuery installed and running correctly, the CadQuery editor, as I feel that's the best way to start using CadQuery out of the box. So, first of all, you can see that I've set up my first and last lines of code, import CadQuery as CQ, and the show object function, which I will use at the end. For this little design, I will be working with some measurements which I will include here, and I do not claim that these are the exact measurements, taking into consideration tolerances and so forth. I have 8 millimeters for the nominal module length, 3.2 millimeters for the plate height, and I will use 2.4 for the toe ball radius and 1.6 for the cylinder radius. So I will go ahead and name my solid my part. And I find it best in CadQuery editor to wrap the whole code in parentheses, although it's not strictly necessary in other environments. When I pass front as an argument in the work plane function, I'm effectively selecting the front plane, which is basically the XY plane. I will then call the sphere method and pass a single parameter, the radius, at 2.4. Now let me just make sure that I've written my part in the show object function as well. Note that even though I select a work plane, the sphere is not tangent to any work plane, but rather the center of the sphere is the origin, which lies on the selected work plane. Let's now call the cylinder method, which requires not one but two arguments or parameters. First the height at 8 millimeters, and then the radius at 1.6 millimeters. Note here the orientation of the cylinder. As mentioned, the front argument kind of refers to the XY plane. I can go back and even change that. The effect is here as if we had created a circle on the XY plane and extruded it in both directions with a total height of 8 millimeters. But note what happens if I had selected the YZ plane. The orientation now changes, and again it's as if I had extruded a circle sketched on the selected plane in both directions. In other words, the orientation is relative to the selected plane. Let's now call the box method, which of course requires three arguments. We will use the dimensions 8 millimeters, 16 millimeters, and 3.2, which is like a 1x2 Lego plate. Again, instead of front, I could have used the XY argument as the selected plane. Notice then that you could think of the first argument, 8 millimeters, as the X value, and the second argument as the Y value, and then of course 3.2 would be the height or the Z value. Note what happens if we go back and select the YZ plane instead. In that case, the first argument, which was 8 millimeters, corresponds now to the Y value, the second argument, 16 millimeters, to the Z value, and of course the height, or the 3.2, is actually now passed to the X value. So again, the dimensions of the box correspond to the plane selected. Now let's start putting our solid together using a square base of 16 millimeters by 16, which is the nominal dimension of a 2x2 Lego plate. That will go on a new line, and on the next line, let's see what happens if we start with the cylinder. Notice that if I simply parse the arguments 8 millimeters for the height and 16 for the radius, the cylinder is actually centered around the origin as before. In CadQuery, you essentially need to change or select the face you would like to work with. In this case, we will need to call the faces method. And one of the ways we select a face is to pass the greatest X, Y, or Z argument, or however you want to describe these characters here. I will use the greatest Y argument. But even in this case, the cylinder now has been shifted, but the orientation is not as I intended. I would need to pass the work plane method, which creates a new work plane on the face I selected. And now the cylinder is once again created with the correct orientation, as if I had extruded in both directions a circle sketched on that new work plane. I will need to change the parameter to 16 millimeters in order to get a bar that essentially extends 8 millimeters away from the base. What happens now if we just go ahead and add the sphere method? Again, the new object is centered around the main work plane origin, or the original center. I will need to once again call the faces method, but this time when I pass the greatest y argument, as I did before, I'm essentially selecting the tip of the cylinder, which is now the face or part of my solid that corresponds to the greatest y value. And I will go ahead and complete the line with the work plane method, and there you have it. Specifically with the sphere, it might not be so necessary to call the work plane method, and that's because of the natural symmetry of the sphere. Of course, we will get the same solid. There you have it. That's our rough modified Tobal Lego plate modeled using three basic solids.